right, and welcome to the latest Trees Around the Globe Student Research Campaign webinar, and this is State of the Trees, February 2023. And we're going to do things kind of a little differently here. We're going to start off with an odd poll, okay? And hopefully it goes through all right, because I'm working it on my browser. But, and Peter Nelson can add on to this, but we're doing this poll, and it has to do with, we're going to ask you to choose your personal height range, okay? Because as you know, what we've been doing is, several webinars, we've taken some of the globe data from different countries or different locations, and we've created these graphs of the distribution of tree heights, within certain time periods and across different areas of the planet, different regions, and globally as well, that have come into the globe database. And what we're going to do is we're going to, ask you for your height and kind of create a distribution that way. And don't worry, it's anonymous. We won't tell anybody how tall you are. So don't worry about that. But I'm going to just pop this poll up now, and let me know if it actually pops up here, because like I said, I'm working from my browser here, due to the whole NASA firewall issue, all that stuff. So I'm going to launch this poll now, and Peter Falcon, let me know if you see this pop up.
Yeah.
All right,
yes,
cool.
We do.
So yeah, so if anybody answers the first one that you're 60 centimeters to 72 centimeters, that's going to be kind of a skewed poll, because that means you're extremely short. But if you could just pop in there, what your height is, and then we will have that. And we're doing this because, as I mentioned, and since we do that distribution of trees, we wanted to see this as well as far as the participants. So Peter Nelson, would you like to add on to that? Because I know this came from some ideas that you were having with some of the things that we're doing.
Oh, but of course, I'd gladly add on to this. And part of this is thinking about what we do with the numbers and what we do with the data after we've collected it. And so, this to me is a nice little way that we can start thinking about our community around us. Even here we are, a nice virtual community, and we're kind of curious, what is the distribution of height? And does that relate to anything? Is there sort of a maximum height of our participants? Or, what's sort of the shortest participant that we have that would be counted as a tree? In our globe world, apparently you have to be at least 5 meters tall to ride the tree ride and to be counted as a tree, right? So there is this really interesting thing that when we think about height, it goes to classifications. And so, Brian did a good job here of giving us ranges rather than making everybody type in specific numbers. And we did that on purpose to make graphing easier, to make some analysis easier, and to also protect people's privacy. We didn't want exact numbers tied to people. So by grouping numbers like this is another way that we can look at overall trends and also start thinking about the overall population. And if we were all standing in the same room together and ordered ourselves, what would our graph look like?
Okay, thank you, Peter. And since I, launched the poll, I cannot answer, but I will put it in there because I'm assuming I will be the only person in that 198.1 to 213.3 centimeters, because I'm about close to the the 200 centimeter height mark. So
which is
You're
interesting.
the outlier.
Well, not just the outlier. That's interesting, Brian. I mean, we can think of you as the tallest tree in our community, in our landscape. And I think one thing that becomes very obvious is that height doesn't equal age, does it, Brian? And the oldest person in the room isn't the tallest in here. And to me, that's a reflection that is the same way that we can think about our trees in our community. Is the tallest tree in our community actually the oldest? Or is it a particular species that was living in the right place and got fed the right food and, was born at the right time and had the most opportune, climate to grow in? Or what was it, Brian, that helped you to become the tallest in our community, right? That's sort of like how you can think about, tree height and human height as just kind of one corollary, one dimension. And so, we've given enough people about 3 minutes to fill out our poll. We appreciate everybody for doing that. And so, Brian, let's see what kind of graph we might see, or what sort of numbers we might get back when we end that poll.
Yep. All right. So yeah, it looks like there's still a couple people who haven't taken it, but that's okay. Let's see if something actually pops up here. Let's hope it does. If it doesn't, we can create something on that. But I want to qualify, kind of answer your statement. Is people ask me how did I get so tall, and I always say we had really fertile and organically rich soil in eastern Pennsylvania where I grew up. So because a lot of people in my family are really tall. I'm the tallest, but they're just just a couple centimeters shorter than I am. A lot of them in my family, my brother, my two cousins, my dad, my grandfathers on both sides. So
yeah, and that's great, Brian. I mean, because that does get into like, okay, so that is the investigation that you keep bringing back to us, is what are those limiting factors, or what are those things that actually help to support the tall trees in our community. And I would also peg this at looking at the time that you were around, you were alive, right? Like, what was the climate like during that time? It might have even been a little bit more conducive to that fertile soil. Maybe an extra rain came in. Maybe it was just like perfectly mild and everything was lush and there was just bounty around you, right? But if somebody came along today, a new tree sprouted in that same area, would it do the same thing that you did? That's sort of like that really interesting question that climate scientists have, is this generation that is coming today into the same soil in Western Pennsylvania, Brian, is it experiencing, would they experience something very similar to that, and therefore be able to achieve that same tree height or Brian height as that location. So that's that future forecasting and scenario that none of us know, but by doing these observations and making these measurements, it really allows us to track that progression and those changes, and ask that question: did Brian have better environment to grow up in than the children of today? And what about the next cohort of trees after them? And we always think about trees as a long-lived species. So that's why thinking about time scales like this is important. All right.
Sorry about that. The poll kicked me out. Zoom kicked me out when I tried to end result of the poll.
That is too funny. All right. So at least on my side here, I'm gonna before I do this, thanks for sticking with us, everybody. I'm gonna do a quick little screenshot so that we have that, Brian, in case we need to just pull up the graphic. Okay.
Right, yeah, I can click. There you go. That right here. Is that what you want?
Yep.
Got it. Okay. You got that, Peter? All good?
Yeah. Okay. So yeah, let me pull it up, and here I'm going to drop it into the chat as well. Gotta love real-time teaching, right, folks? This is one of those things that I think we will provide out to you, kind of how to do sort of the same sort of census for your classes, because we do think that it's a great place to do that conversation starter, especially with younger students who are tracking their tree height and their age throughout the whole thing. And so we're just really excited to kind of realize that this is a fun connection. And as you can see, it brings up all kinds of questions and things like, hey, Brian, when were you born? When did your tree sprout?
Yeah.
And okay. All right, so I dropped this into the chat as well, because apparently when I share this, I don't see anything on my side. So, so let's if you wouldn't mind going into the chat and opening this up, and I am going to, let's see if I can share my screen and yes, right there. All right. Okay. So yeah, so this was our distribution graph without Brian being included, and to me this is a great example of we sampled the landscape. We had we tried to get everybody, but we didn't. You know, we tried to inventory all of the height of our community, but for whatever reason, you know, Brian wasn't able to participate that day. He was behind some locked doors or something, like, you know, inaccessible. Just that happens. So we ended up only having a 70% return. So that is actually really interesting to know, because we can think of that uncertainty as we look at this graph, right? We recognize that it's not fully representative. And is that a problem, is a question. Well, in this case, we know that we're missing a data point at the end of our graph here. And that, you know, may not be a good thing if we're thinking about what is the tallest tree and actually knowing what the height of that is. Right now, it would be 6.5 feet is the best that we could say, right? And that might or it may not be true. And we know that's not true because Brian just told us. And what's interesting here is that we can also see that a majority of our participants of our tree community here is in the 5 to 5.5 foot range. It looks like, you know, 1.5 to 1.6 centimeter or 1.6 meters tall. Interesting, right? So none of us technically meet the classification of a tree. We might be a tall shrub or something like that, but that is you know, an important thing to just kind of recognize right off the bat, is how we can sort of use that. And one thing that this tells us is that if we were all in a room together, you know, there would be some edges between our height. We're not all homogeneous. We're not all an even age stand of trees that might have been planted at the same time, or that might have all grown up in the same place, and that might even all be the same species, so therefore have that same growth rate, right? Here, this graph, just through this poll, demonstrates some variation that makes us ask the question, why is there this variation, right? And as we heard, you know, Brian's age does not equal his height, right? So Brian, I'm going to get a little personal here, but like, how long have you been the height that you are? How many years now?
So I'm 48 years old now, and I think I stopped growing, I'd say at about 17, 18 years old.
Interesting. Yeah. And so, you know, you've been the same height. Your tree height hasn't been changing. Maybe other attributes.
It depends on my hair. Depends on my hairdo too.
Right. Exactly.
The leaves are growing.
The leaves are growing. Yeah. Leaf on, leaf off. Right. Like, you know, and whether it's windy that day and really like, you know, messing it up. And so, you know, so there is that really interesting piece that if we think about, you know, trees in our community and how long have they been that height, you can see that even Brian just described a plateau going across that. If we measured him year after year after year after year, which he probably does because he goes to the doctor and takes care of himself, you know, we would have an even age graph. It would all be the same for 30 years, 20, 30 years, right? And so I want to reinforce here that age or the tree height itself does not equal the age of the tree. And that becomes this question that Brian keeps coming up to us is, okay, what is the tallest trees that you have in your community? And why might they be only that tall? And then how long have they been that tall? Have they been that tall for 1 year, 2 years, 10 years, 100 years, 1,000 years? That to me is the interesting thing that we can think about between height and age. And to me, this little demonstration right here, allows us to get in and even ask further questions about other people in this group and further investigate that age versus each one of these little ranges that we've come up with, right? And so height can really lead you into a lot of different questions when you start comparing them together like this. And so, here we wanted to start off with this activity. Brian, keep me on track of time and everything, because I want to now move you into a little bit of a modeling or a graphing activity. So in fact, actually, we did a graph right here, right? We just counted the number of people that fit that height criteria. Okay, so this is something that you and your students can do as well, both in the classroom. You can make a graph like this, and then go outside and everybody measure a tree. Randomly go and measure your own tree and come back and fill out this graph again. How tall were the trees that people measured? Do they reflect the same shape as the height of the students? And you might find that, in your class, everybody's about the same height because they're all about the same age. And you might find the same thing when you go out and you're measuring your trees in the playground or around the schoolyard, that again, they might be the same height and therefore indicate that they might be the same age, right? And so just the shape of this graph is something that we use to think about the future of a community, whether it be forests or whether it be humans, right? Is there a particular age that's on the landscape that we've got to be worried about because, they have, something happening, or they're sort of like they're susceptible to particular diseases or wind or other things like that, right? So that age cohort kind of piece is a great way to go from the individual in a classroom or the individual tree and to think about that community. And that's really what we see when we look at Earth from space, is more that community of trees rather than that individual of trees. But I want to give you guys all a way of thinking about, this age of a tree versus the height of a tree. Beyond just kind of this general shape, because this is actually kind of similar to the graphs that Brian and I shared with everybody that you can find out there for a country. And we saw a lot of really interesting shapes like this that indicated, a lot of shorter trees in a community and a lot less of these taller trees, like Brian. Brian's a rare species, right? There's only one of them that matches that group of things. And that's true of trees around the globe. It takes a lot for a tree to be able to hit that maximum height of that we see around us, and we've highlighted a variety of them in our webinars in the past. But right now, some of the tallest trees are near where I'm at. They're kind of in this like green sort of color like this, but they're actually about 360 feet tall, which is about 100 meters tall. So the thing about this graph is we could always keep expanding this out and compare our height to the height of our trees in our community. And again, do we have sort of the same shape in our tree height and human height in our community? Okay, so with that, let's hop over, and I am going to go over to a yes, here's where it is, to a spreadsheet. Okay, I am going to start off here and just show something. Let me see. Got that. Getting this poll out of my window. So what I wanted to really highlight is how trees look on the ground, right? And how that tree height really obstructs our view of the sky and becomes very visible in our satellite images. And you can see actually the difference between an area that has no trees, water, barren land, even grasses. You might have some trees out on the edges. Shrublands don't have trees, or don't really have, they don't have trees. Our cultivated area, and even our urban areas, are places that we don't expect to find trees, at least our pure classes, the way we define those. So again, one of the characteristics here of this particular land cover class is that height. Okay, so one of the things that we could do here, and I'm going to go down and go to another sheet, because I want to demonstrate a really simple model. And I'm going to start off with the idea that you have measured a tree, and you already have a height of the tree. But first, we want to look at a null hypothesis, right? And kind of give us something to compare what you measured to a general model, a general growth rate model. And again, thinking about our trees. So it's really simple, right? Like, what is the year, or let's say, date? And I'll actually say year, and then I'll say month. And then I'll say tree height. Just like what we have in the GLOBE database, or what you record. So I am going to start off with, a really simple thing, really simple scenario, and a simple model. With that being, we've highlighted many people who are planting trees. So that really makes it easy to know how fast trees are growing. If you know that you put it in the ground, or that you germinated that seed, you know exactly the age of the tree. So we're going to start off with the idea that I know the age of the tree. I started it from a seedling in my classroom, and we're going to go plant it outside. So I did this back in the year 2021. And I actually started it, and it's actually sprouted in the month of May. And it had, 0 meters of tree height. There's nothing to that seedling at the beginning. And here I can say, that's its birthday, right? That's the birthday of that tree. And that's a wonderful thing to know, is knowing that exact date like this. So if you're one of those groups that are going out there and actually planting trees, this is something that you can pay attention to. And maybe it's something that you can celebrate each year by going back and remeasuring that tree and celebrating its birthday on the same day that you were out there, right? We're going to say here, this tree we went back and it grew 1 meter in that year. I mean, wow. In 1 year, that it grew that fast out in that nice fertile soil of like Brian was growing up in, right? And so, each year I'm going to go back and I am going to celebrate its tree birthday with it. And it seems like it's just growing at this steady rate, consistent rate of 1 meter every year. And I keep going up. I went back the same year. Oops, typo, right? Always check your data. Went back, and what's interesting is here we can finally start talking about this as a tree, right? I think this is really important. At year 5, it finally gets to celebrate changing classification in the GLOBE world. It's like becoming a teenager or going off to college. It has actually gone from, being a seedling, maybe surrounded by dirt or surrounded by grass or surrounded by other things, other trees maybe, but it took 5 years for it to become what's known as a tree in the GLOBE world. Okay, and the nice thing is, we can come in here, and I am going to just, keep this going, and just continue this growth rate out to, looks like let's take it out to a nice even year. Yeah, all right, out to the year 2070. And the nice thing is, we're just going to keep celebrating its birthday all the way through. Oh, it wanted me to go back on different days. We're doing anniversaries, right? And again, thinking about how we track our own height is, anniversaries. You go back to the doctor at the same time, at the same month, maybe ideally same day. You have a particular rate of change and number of days that you can actually compute. And we want to reinforce that, that's a consistency that scientists want to have, so that when we say this tree is growing at 1 meter a year, a growth rate, a change that requires 2 dates, 2 observations, that it actually is a consistent rate of measurement, right? So that's something that is important as we think about calculating a rate of change for our tree height in our community. Okay. The other thing is, I will just continue, taking this out. I'm giving you guys a little bit of some tricks to make a consistent linear rate. Apparently, we're going out to 49 meters as our tallest tree if we go at 1 meter a year. And maybe at this point we come back and the tree is no longer there. So our observation ends in the year 2070. And we would expect, after so many years, we'll look at that, that tree would be 49 meters tall. And so that's this is a nice way that we could calculate an expectation of our tree height into the future based on a simple growing 1 meter a year as just a general model. And then if you are able to go out and remeasure a tree in your community, or if you are able to track tree height at 2 different points in time, you can also start calculating this tree height growth rate. And that's always a question that people have is, if I plant a tree today, how long will it take for it to become a certain height? In our case, it's going to take 5 years before it can become a forest or a group of trees. And we now have a hypothesis that we've set for the class of 2026, right? What is we expect those trees that we planted in the year 2021 to actually be 5 meters tall when they go back. Is that right? And if it's not right, if there's a difference, maybe we go back and we remeasure this at 7 meters, right? We'll call this remeasurement. We can then, do a difference where we just say our remeasurement minus our original, and we get a difference of a certain amount. And as you saw, we were expecting, a growth rate of 1 meter a year, right? So I'm just kind of filling out this spreadsheet on the fly with you guys, but you can see that we'll want to expand out and do a little bit of calculations between our model or our expectation of what our tree height would be, what our remeasurement might be of that tree. And then we can compare what is happening in reality versus a model, or what an expectation of the future scenario might be. And what I find exciting about this is that this allows you to start thinking about the future of your own community. If you measure a tree at this height today, well, how long will it take for it to become the tallest that it can be? And will there be the GLOW program there to help measure those in the future? Will the next students in the community be able to go back to those trees and remeasure and see whether your prediction of tree height is actually what that tree grew up to be? I mean, Brian, I'm going to bring you back into this conversation at this point and ask the question. When you were 10 years old, was anybody predicting that you would be the tree height or the Brian height that you are today?
When I was 10, not this specific height, but they knew I would grow tall, but they weren't aware of how tall I would be.
Right. So you had there was some uncertainty around that future scenario, right? And the uncertainty really came back into maybe your diet, maybe the food, maybe the other environment, other stressors that you might experience that might keep you from becoming what they were predicting, right? So I love this because the further out you went from 10 years old, my guess is they had more uncertainty in terms of how tall you would end up being. And that's exactly what us scientists are doing as well, between having a simple model that is 1 meter a year of growth, and then going out and getting some reality checks with, oh, this year it grew 2 meters. And then you might go back and the next year, and maybe it actually only grew 1 meter. Again, that gives you an indication of something more to investigate of why is there this difference in this timeline that the tree is recording in its tree core and in its life as it interacts with the atmosphere and the soil and us humans. So I wanted to spend a moment here to just kind of highlight, at least, here's a way of doing a simple model like this. And one thing I am going to do is I'm going to actually get rid of my month. And I'm going to show you how to make a simple graph here of, let's see, we should be able to do this quickly. Yes. Okay. So this is our simple model, right? So this is a simple linear model that is our null hypothesis for tree growth in my community. And it gives me something to compare my measurements to this general hypothesis. Okay. Now, I made this up, right? I just said 1 meter a year. Now, this is where a little research, I might find that for the species in my community, maybe they grow faster than that. Maybe they grow slower than that. So you can do a little literature review to help students get a sense for that. But there's also just a nice inquisitive nature here of, 1 unit per year, or based on their experience, what do they think the growth rate could be? So again, this could be a null hypothesis that the group comes up as a consensus, and then you go out and measure some trees and you try to figure out, when was it born? And try to calculate that age versus height relationship. And that gives us something that we can think about carbon, we can think about all kinds of different things after that. But this simple linear relationship is a good way for us to start building a little bit of graphing, a little bit of thinking about the future, thinking about, what is the limit of the tree height in my community? And at what year will the tree that I planted achieve that? When will it become a Brian? Or is it going to get hit by a hurricane and it will turn into a Peter Falcon? Height, right? I'm sorry.
No, I was laughing too. I was just muted.
So I thank you guys for allowing me to kind of dive into a little bit of modeling, a little bit of graph work, a little bit of just, how to work with a spreadsheet, how to start taking data out of the Globe database and start putting it into a timeline and being able to understand what you're measuring compared to a predictive model. And in this case, trying to predict what is that maximum tree height in my community. Brian keeps bringing that question up, and I'm always stumped by it because I don't know what it is, and is it going to keep growing at this nice rate like this? Or is there some limiting factor to tree height in my community that I will be able to find out a little bit more about as I test, what is the maximum tree height in my community? All right, and with that, Brian, I'm going to hand it back to you guys.
Thanks, Peter. And do you want to come back in then with anything else to add on to it, or because we had the RSET thing that I'll introduce and then I can pass it over to you again if you want to.
Yeah. Bring up the RSET piece, and I'll highlight why I just kind of went through what I was doing in terms of the modeling,
Right.
Piece of things.
All right, let me go and pop on. I'm going to share my
And let us
screen.
know if you have any questions about that. That was sort of an on-the-fly modeling activity that we haven't written out full instructions for, but it's something that we wanted to bring to our group and discuss this idea of not just measuring the trees, but having a hypothesis that you can compare it to, and being able to do a comparison and look at tree growth over time and think about what is expected versus what is actually happening.
Yep, and I did reply to Batya from Israel in the chat. Her question was, are there any data on trees that have stopped their growth that is maintain a constant height? And I did actually recently watch a TED Talk on this specifically, that there's been a bunch of studies on this. So it's a really cool TED Talk. I put the link in the chat and I replied directly to your comment, Batya. And then also, I learned actually not too long ago, so it was kind of pretty cool that you asked that question, is that they were taught. I read an article about something called hydraulic limitation hypothesis, and it has to do with the basically stopping of tree growth with certain species of trees. And you can learn a little bit more about that in that TED Talk, which is really cool. So check that out. So,
yeah, and I love that. I mean, this is a really important question, that goes back to that. Like Brian, or like many of us, we did all stop growing, and we do have that constant height. And so, this is where it gets interesting, where you can actually, there is a maximum height for different species, depending on, in some cases, the environment that they're growing in, or the climate that they're growing in. And I'll bring up the example of redwood trees. One of the tallest and oldest species around, and these are the coast redwoods in California. I wish I could change my background, but I don't have that up right now, because they grow in this really small, narrow strip on the western coast of the United States, and they are some of the tallest trees around, at anywhere from 300 to 365 meters tall, or feet tall, about 100 meters tall. And they do have that hydraulic limitation, right? How much water could they actually pump to the top of that tree at 360 feet tall? It takes a lot of work to move that through. And so, they kind of have a limit on the height that they get to, based on the amount of water that they actually get, the timing of that water, whether it only happens at certain months of the year, or whether it's consistent, right? And that moisture is something that's always there. And then, some people decided to take them to New Zealand, and they put them into the ground in New Zealand, which has a different climate, and they had a very different growth rate. And they are actually now on track to become even taller than the coast redwoods and their original range. And so this is, again, kind of one of these things where we like to think that there is a general model for tree height growth, certain a meter a year for that species. But there's a lot of factors that go into that might limit that, including water, including climate, the number of days that it's not freezing, I want to emphasize things like wind, actually, is something that really limits the height of trees because it blows leaves off and branches and can limit photosynthesis, as well as just shear them off. And we saw that especially hearing from Malta, and and the shape of their trees actually reflecting the amount of wind that comes through that area. And so there tends to be, when you start looking at the satellite images, this is where it gets really interesting. And I have this good demonstration behind me. These green areas are areas that would be all the same height, all the same tree canopy height, all the same age. And a lot of that, we see that a lot when you have an area that you go out and you plant the tree all at the same time. They're all going to grow at about the same rate. And so the sunlight will reflect in kind of the same way, and you'll have an even age stand. You'll have just like a lot of the same numbers going across. In contrast, over here, kind of this model or darker green, that's an area that has a variation in height, a little bit more texture, if you will, to the picture, and sunlight. And so it actually has more shadow to it. And so you can actually see the difference when we look at these things from space. You actually do get an indication of whether it's an even age tree stand that might be planted at the same time or have the same age, or be a little bit more variation in terms of its height, and indicate that there's just more complexity to that location than this more static, consistent green color like that. So pay attention to that tree height and whether it's consistent or whether you have a lot of variation to it. It tells you a lot about that landscape, and that's what we're trying to demonstrate with these different ways of thinking about the future.
Hey, Peter, you have a few questions in the chat box I wanted to get to.
Yeah.
Yashra asks one. He says, what are the tools that can be used for phenology study, especially for evergreen trees? Yeah. And are there any web tools available for phenological analysis?
Yeah, that's a great one, because it has been a capability that is getting better and better and better. And essentially, what we need is repeat observations in the same place. And so you, with your Globe Observer camera, and even just going out and doing repeat measurements of the same tree, you can do that remote sensing phenology piece of things that help you to understand really important characteristics that you'll see in the satellite imagery. And by that, I mean, when does the tree leaf out, right? This is one of our questions that we have. When is the timing of that? Does it happen in April or May? Or, as this question implies, is it evergreen? And therefore, you have green on the landscape the whole entire year. So you should be able to go out and take a picture and have a picture that is more green, kind of like what's behind me, than in another location that doesn't have tree leaves. It doesn't have that green component, right? So that's the key piece, that whether we're looking at a location on the ground or from space, we're looking for that green to be there. And so, the big challenge has always been being able to see through the clouds when that green up happens, and also when the green down happens on the other side of things. And so that's where the satellite images, sometimes you have to look across the whole summer and just see, when do you have a clear image that allows you to see the green of that location. But on the ground, that's where you have a little extra superpower. You can actually record exactly when the phenology happens. And NASA and many other people are working on trying to improve that ability to see green up from space, but we always have that cloud in the way. So we will actually highlight the phenology piece next month in our conversation about thinking. Now that we thought about this one individual tree, thinking about it over time, or thinking about its growth rate, the next thing is actually bringing up this question of, I didn't plant that tree. How do I know how old it is? How can I figure that out? How can I deduce that? And so one of the things that we will highlight is actually thinking about when the best time of year to measure that tree is, because trees aren't the only green thing on the landscape. And I'd say the nice thing is with evergreen trees, you can then choose a time when everything else is not green, like right when there's grasses or when there's shrubs or other things that aren't evergreen. You can actually use that to your advantage. So I hate to always say this, but come back next month and when we'll dive into this phenology piece a little bit more, because it gets into the piece that we introduced today, which is what is that growth rate of change? And we can think of phenology in the same way. When is the leaf on? And has that been the same? When does it leaf off? And has that been the same? And that all impacts that growth rate, because without leaves, a tree can't photosynthesize.
We have two more questions, Peter. One of them is from Ana Preta, from Argentina, and she asks, the environment sometimes limits growth, e.g. in high mountains. Could we analyze the changes in the high mountain tree line and its height relating to the increase in temperature?
Yes, Anna, we can. As I said, the really important thing that you capture both on the ground with the Globe Observer land cover photo, just a rapid assessment, or when you do the tree height piece, is the fact that trees cast a shadow. Okay, so if we think about that, that as trees grow, they will cast more and more of a shadow, and therefore our pixel will actually go from like this green color, like right above me, this neon green color, to something more like this darker green color. And that kind of goes back to that same phenology question. We actually, might see that that early on our leaves might be bright green like this, early on in the season, but then later in the season they might just shift to this green color as they go through their process and eventually, lose their leaves. So, there is a lot that we can learn from that shadow and the height of those trees. And Anna, to your point, we are expecting, scientists have predicted that tree line, where the upper extent where trees are located, will be changing, and it will vary depending on your locations in the world. And so that's what we need to monitor, is just get out there, and there will be different growth rates of this. But I want to encourage everybody to help us identify where is the maximum elevation in your community that has a tree on it, right? Where is that edge, as we call it, between tree line and not tree line? And what's important to recognize is that there's both an upper limit and sometimes there's a lower limit as well, right? So that elevation piece is something that when you look at the globe classification of a tree, we do need to know the elevation, because it tells us a little bit more about the climate that it's growing in. And the trees and its growth rate can be a proxy or an indicator of our climate. And I think that's a really important thing to answer your question, Anna, of how the two are related. Sometimes it's a one-to-one relationship where you can see for every additional day of growth that tree can have, it grows a meter. Other times it's a little bit more nuanced. And but to me, focusing on these edges and these lines are a really interesting place, because scientists are predicting that that's where we will see a lot of our changes. And let's see if they're right.
Last question, Peter, was from Miss Bethany Aboa Adam. And she asks, some trees grow horizontally by adding on branches. In this case, how do you determine the height based on this model?
Yeah, so that kind of gets into this important challenge. We made an assumption that that tree is going to always grow up vertically straight at a 90-degree angle, right? you can actually change that growth rate. You can make it that assumptions a little bit more specific, a little bit more tuned, in this way of both thinking about the horizontal canopy growth, right? Like how wide is that tree growing, in addition to how tall is it growing? And I want to highlight this because when we talk about what a satellite is viewing, or what ICESat-2 is viewing, or what NASA is viewing, it really is that the top of the tree canopy as much as anything that we actually see out there. And so, you know, we want to really be thinking about that aspect of what's out there. And I'm going to bring this up because we want to think about how wide that tree is, because again, you know, sometimes the tree might stop growing tall, but it might actually start growing wider. And we see this with a lot of our trees, that the diameter actually starts getting bigger over time. It may not grow up at the same rate, but it might actually put on more volume of wood and therefore have more efficiency to keep the leaves alive. Right. So this is something that is not in Globe Observer itself, but is in our Globe protocols, which is paying attention to the canopy. Because again, you know, you might see something green on the ground, in this case, shrubs, but we want to think about where they are, where that greenness really is. Is it off the ground in the tree canopy? Or is it actually on the ground where we can, and satellites can confuse it with a variety of different things? In this case, shrubs after a fire, right? So I do want to encourage the multiple ways of starting to think about the landscapes, and definitely thinking about this satellite perspective, where sometimes the trees are nice and obvious, like right here, where we've got a nice row of trees, we can see the shadow. Other times you can't really see them because they're buried in between buildings. Right. So this is where we need everybody's help to kind of match this view on the ground versus the information that we're able to get from above.
And the last comment, sorry, Peter, I was saying last comment from Anna. Basically, everyone that you answered a question, you just say thank you very much in the chat box. But she says one of the biggest problems is going up to the mountains is to use the Globe Observer in high mountains. Is this something, and I think you may answer this already, but she had said, you know, perhaps via satellite would be a better option rather than the Globe Observer in these areas?
Yeah, so I want to emphasize that Globe Observer is really an observation tool. It is not a navigation tool. And so whenever I'm in a high mountain environment, and I've highlighted some of these myself, or in an area where my cell coverage is not very good or my location services are not very good, I will actually use a different device, a GPS device, maybe a separate one that I use to navigate my hiking terrain with, or that I might be using for my navigation purposes. And so use a navigation app or navigation tool in the same way that you would to navigate around a high mountain environment. You can then either pair that up with a Bluetooth sometimes to your phone, and it will then read that, or you can always type in those coordinates from your GPS into your Globe Observer so that they are the correct location. Because the map doesn't work, right? If you're not online as well. So having another way to confirm the location is a really important step as a scientist. And sometimes if we use just our phone, we might take that for granted. And in a high mountain environment like that, or in an area that just has lower cell phone coverage, location services coverage, it definitely can make a little bit of a difference by pairing those two things together. So navigation and observation. That's kind of the tip that I've really used with this. And then the other thing that I would highlight that you want to do is, after you have put your data into the Globe database, here's a great example of one of the transects that I've did going up in elevation to actually get tree height, or to get that tree line with things, is check the location of your data, right? this is an important step in verifying, especially if you're in an area where you can't do it within the app. You want to verify it when you're going up. And I also recommend, I fall into the trap of just always looking at this one because it's default. But remember, you can go in here and you can turn on, say, the hybrid satellite map and actually zoom in to your locations. And here is a great example of a location where we see sparse trees that are right in that tree line area that might be expanding, but maybe they will actually end up dying out because they're not getting enough moisture or something like that. So here I actually did a nice observation that we can see. I can double check that in my location here. And, again, a little bit of a rapid assessment, but we can see this is a bit like, tree line, and we can actually see some dead trees and dead carbon that is still on the landscape. So we'll come back to what happened to those trees. How do we investigate that next month? In our next one, as we've discussed, how fast are these trees growing? We've got a hypothesis. Now it's up to us to go out and sort of double check that and do some comparisons.
Thanks a lot, Peter. It's always amazing to see how life exists. I remember being in Colorado and seeing trees basically splitting boulders as they grew sideways and then suddenly just turn upwards and start growing upwards. And it's just amazing to see as they crack these boulders and the way that these trees survive somehow.
Exactly. And I have a couple examples myself here in the lava fields in Oregon, where you have a couple single trees, and it all comes from the edge of where the seeds are, where the edge of the forest is. And that's something that we'll talk about. Thank you, Peter. That was a perfect segue. Again, if you have an open area right next to the tree you measured, how long or can it actually, help provide seedlings, and what would its growth rate be before that meadow actually was full of trees? So thinking about that growth rate isn't just important for that single tree, but it is important to think about how does an area recover after a forest fire? What is that growth rate? And when would we expect to see trees recovering in these locations?
Excellent. Thank you very much, Peter. There's one more question in the chat box. If you can go and just answer that in the chat box, because I know we have to move forward. So I'm going to turn it back over to Brian. But thank you very much once again for enlightening us with so much tree knowledge.
All right. Hold on 1 second here. Peter, can you see that on your screen?
Yep, looks good.
All right. So, jumping back a little bit, thank you, Peter, for that awesome discussion. Everybody always loves when Peter comes on because, I don't think there's a question he can't answer when it comes to trees and land cover. So, but once again, happy Valentine's Day. If we didn't say it earlier, some people said it in the chat and things like that. But here are a couple cool little NASA, Globe Observer, Globe program, happy Valentine's Day messages. So, very punny and funny. So, check it out. So then I also want to mention that next, Peter referred often to next month's webinar, and it will be on Tuesday, the 7th of March at 1 p.m. Eastern Time, 6 p.m. UTC, 7 p.m. Central European Time. And this will be the State of the Trees, March 2023. And we will have scientists and experts from the JEDI mission that you've heard of often. It's the Global Ecosystems Dynamic Investigation on the International Space Station that measures tree height in basically the mid-latitude area between around 56 degrees north and 56 degrees south latitude. And this topic will be May the Forest Be With You, mapping ecosystem structure and understanding global carbon balance with JEDI. So we have the ICET-2 mission, an independent satellite, taking observations of height around the world, and tree height is one of the observations and measurements that it can take, but it also looks at, the ice levels, it looks at the height of buildings, it looks at the height of bodies of water, including the oceans and rivers, lakes, and all these things. but Jedi focuses just on tree canopy height in specific latitudes because it's following the orbit of the International Space Station, because it's an instrument on that space station. So, stay tuned for that. You'll see some info coming out with that as well. Just these quick metrics here that we're going to jump back to. We've got a lot of measurements coming in all the time. We have over 14,000 measurements already in for just this year 5 of the campaign. And total, we have we're closing in on 140,000 observations from over 47,000 global sites since we started the campaign on September 15th of 2018, coinciding with the launch of the ICESat-2 satellite. So I'm going to do this, and I'm going to pass it back to Peter towards the end here, but we have something here that we had in the description you might have seen, and it's a call to GLOBE program students with the Trees Around the Globe Student Research Campaign. If you remember, a couple months ago, we had the communications director for the Globe Observer, Autumn Burdick, on here showcasing some of the student vlogger students who were interviewing family members and elders and locals in their community about what they've seen changing over time in their environment. We wanted to make this a focus of this campaign, where we look at the trees specifically, and in these trees you can also discuss, ask questions about, to your elders, to the elders, or you have your students, go to their elders to create these videos and looking at the changing of trees and the changing of land cover in their local environment. Because as you know, we're always focusing on what's happening in the local environment, so we can paint a bigger picture of what's really happening globally. And that's the whole idea of the GLOBE program. Take local measurements, share it with the rest of the world, these 127 GLOBE countries, and get that information out there so we can see what's happening with the global picture of a changing climate. So here we go. So what we're asking for are approximately 3 to 5 minute videos. And if they're a little shorter, that's fine. A little bit longer, that's fine. This is just kind of a baseline here, which we're going to showcase during some future campaign webinars during year 5. And we want students to, even if as teachers or GLOBE country coordinators, GLOBE partners, want to interview people, older than you, in your community. Maybe there's someone in your community, who's, 90 years old, 100 years old, something like that, that you might want to talk to, and ask them, what's happening in your area? What have they seen over the last 10, 20, perhaps 50 years? And in that, talk about, where are the trees in my local area? How tall are the trees in your area if you've taken measurements, or you can estimate these. We'd like you to take the actual measurements, but we know you don't have time to go take tree height measurements of every single tree in your local community or environment. But are the trees in your area getting taller and denser? And really discuss with the people you're interviewing, or your students are interviewing, or maybe you have someone in your family interview you, or interview maybe your son, daughter, or grandson interview you, or interview other people in your family who are older, who are the elders, to showcase this, because that's what we did with the student vlogger program this year. But we really, I should say, last year, into this year, but really focus on what are the changes they've been seeing over 10, 20, and 50 years in that area. And we have an example here. I'm going to make sure my sound works okay, but I'm going to flip back to that in a second. Well, what I'm going to do is I created this data, kind of a question sheet, data sheet, kind of guiding you through, how to do these videos, and what you can do. But I will send this out as a PDF when I send out the email to everyone on the campaign list, when the recording of this webinar is up and ready. I will send this as an attachment to that email, that PDF, so you can grab that. We will also put a link to it on the GLOBE webinar webpage, where on the webinar page where I post the recording of the webinars, and underneath I have associated links and materials that we discussed during the webinar. I will also include this. I'll upload it to the GLOBE website, and then I'll create a link that takes you directly to this as well. And this is just kind of a guide, a step-by-step guide of what you can do and share with students, or anybody who you think would be good to create these videos. We really want to showcase these. But I also should mention, and you probably all know this by now, but if we're going to create videos, we have to have these releases. And I'll include these two as links as well. But as you know, there's media releases that need to be, set up. If you already have it done for your students, that's fine. But uh, we have one for adults who be shown, and then we have one for the minors, the students, where it has to be signed by a parent or a guardian. And you're all familiar with this because a lot of you have shared images and you've created videos, and you know how this works. And because the GLOBE program is primarily funded by NASA, we use the NASA media releases for this. And once again, I will share this with you. And if I get a video and I don't see this, I'll contact you or someone, to please get this, because we can't really share this information. We can't share the video where it's actually showing the minors and the adults without having these forms signed up. So I'm going to go back here and see if I can actually go into this. Oop, it won't let me go into that one. So I'm just gonna. It was a highlighted link, but I'm going to go ahead and exit here a second so you can check this out. You should be. I have it up here right now, so I'm going to stop sharing that screen. There's lots of screens open here. I'm going to go ahead and share my screen again. So I'm going to go directly to the video, and I want to just show you an example of what you saw back with Autumn Burdick a couple months ago. Kind of an idea of what the students were doing as part of the student vlogger program to ask the questions to their elders. I'm going to showcase one based on time. It's going to be a student from Thailand who was talking to her grandmother about what has been changing in this area. So Peter Falcon, I'm going to share this and let me know if you can hear it, because Zoom's been a little odd lately. So let me go ahead and share my screen again. I'm going to just share this window. All right. All right, I'm going to do a quick test here. Peter, can you let me know if you hear any sound?
No sound. Oh, wait, now I can hear it.
Okay, it might be just a quick delay. Okay, cool. All right, so I'm going to make this a full screen. And all right, let me share this. This is the student from Thailand who is asking her grandmother. This is the kind of short interviews we're looking for interviewing your elders to see what is changing over time, what they have noticed over their time. Here we go.
Brian, there's no sound, but we do have the caption, so we can read it.
Okay. Okay, let me stop sharing that. So yeah, that was just a quick example, and I'm going to show a couple more, but we don't have a lot of time here, and I want to pop it back to uh, Peter in a second. But let me go back and share this. Sorry, that's jumping back and forth, and I apologize for the strange non-sound from Zoom. So okay, yeah, that's enough about the whole Zoom issue, but that's what happened. So let me go back real fast here. I'm going to pop back into this window here. But as I mentioned, once again, I'm going to include these here, and please feel free to reach out to any of us with any questions about this. And there's no specific, we're not going to say we need this done by next week or the following week. When you can talk to students or, get these videos, created, we're only expecting, we love to have like a handful of these that we can showcase. So that would be great. We'll give you a nice, cool digital certificate for the students who do it, a nice digital certificate, which would be, I'll send you a digital certificate where, you can print out and do whatever you need to. That would be really awesome. It would come from our campaign team, from our campaign. So we will share this as well. So, towards the
Actually,
end of
Brian, go back to that really quick. Then I'll transition into this. I like that slide. Yeah. So as I was going through that, I wanted to sort of emphasize that one of the things that we'll be talking about next month in our webinar is how to take that interview and turn that into investigative questions. How do you tie that together with some of the techniques and some of the things that we've highlighted here? How do you use some of the satellite imagery to provide evidence for what was put forward, that there's less trees in this area? Well, NASA has a lot of supporting materials, satellite imagery, and other sort of products that can actually provide a little bit more parts of the story, other media pieces that can come in with this. So, for me, when I think about this interview with the elders, it is very much a literature review as much as anything. But you are looking for what other people know about the area to inform your investigations, so that you are doing something that is informed and not just making things up, right? And that's the difference between science and something else. And science is informed by our elders, by those that came before us. And sometimes it really is just repeating and going literally back to the places that they are describing here and making measurements today, and allowing us to not only look at expertise as something in a magazine, right, or something that is in the ivory tower. It's actually all around us, and it's another line of evidence here. And so I wanted to kind of emphasize that, because I heard a lot of things that if I was going to want to investigate that area, I now have a list of all the things that might have changed, that I might want to be looking for as I think about the research question I have in this area and the approaches or the tools I would use to answer that. So, Brian, I wanted to start off there because that's how it all ties together. It's not just really an extra activity, it's actually part of your research. And I love this because, for the students, it might be a search, but, for the community, it might be a research. Other people might have actually done that. They might have measured the trees in the community, right? So that kind of leads us to where we're moving this year. So Brian, advance a couple of slides. And that is, this connection between these ground measurements that we have and all of these things that NASA is doing, all of the imagery that it's collecting, and the way that NASA is describing the diversity and what's in particular locations around the world. And so there is this piece of things that we were able to highlight in this particular training. And so in there, I showed how you can actually make this connection between our Globe Observer data, our citizen science data, our community data, and some of the things we've highlighted in our campaign over the last couple of years, the remote sensing side of things. And really NASA is going, going down this path where they're trying to open up and produce and help us all understand open science. How do we work together as a community, a distributed community, working with databases and multiple measurements in service of our local environment and understanding, but also in a way that allows us to have that global perspective. So I encourage you to take a look at all these examples of other projects out there, including Globe Observer, and how they are connecting to remote sensing. And there's a lot of remote sensing lessons, for those that want to take it the next step further and want to apply this. RSET, the applied remote sensing and training program there at NASA. I had to read the exact terminology because acronyms, right? We're in NASA. They actually have a lot that will answer some of these questions about how do I make a land cover map? What data do I use to answer my question? They have a lot of trainings that will supplement what we're doing here that might provide the exact workflow that you want to do to bring in your Globe Observer data or Globe data, your tree height measurements, together with NASA's particular skill set. So we just did that about a week ago or 2 weeks ago. It's now up and live, but come back in March and you will hear a little bit more of an expansion on what I briefly highlighted there, which again is thinking about our changing landscape. And tree growth is one of those things that is changing on our landscape, right, Brian? And it requires, multiple measurements, and it requires a database that can help us manage that information. And then it requires us to have some workflows together that allow us to answer this. So to me, it's really an exciting time at NASA and within the GLOBE program, because the GLOBE program has been doing this for 25, 27 years now. And the depth of data we have is nowhere else. So when we think about change over time, the GLOBE program is poised to help every community implement those yearly programs that allow you to know, is the tree growth continuing at the rate that we're expecting it? Or is there something that is impeding it? Climate change, local pollution, what is it, right? But we need to have that prediction and our expectation versus what we're seeing in reality. And that's the whole idea behind modeling and forecasting.
Excellent. As you can see here on the bottom of this smaller graphic, we have water, natural hazards, biomass, agriculture, public health, and urban environments. All of these things have an impact on all those observations you take, whether it's with the NASA Globe Observer or with the traditional GLOBE protocols, the 50 GLOBE protocols that are up. I think it's less than 50 now because some of them going into sunset. But all of these things are things that have an impact on those observations that you take, whether it be tree height or land cover, or even surface temperature, or air quality, looking at soil moisture in agriculture, mosquitoes, of course, with public health and urban environments, and in observations like Peter was talking about earlier. Sometimes when you're looking at the trees in an urban environment in a city, it's often hard to see from space because these trees may be in the shadow of a building or something like that. So all of these things come together. And I just realized, Peter, that I think there's two things at NASA that are actually called TOPS. So I have to there's an open science one, and then there's the TOPS terrestrial observation prediction system. So I'm not sure why there's two of them actually.
That is so great. I mean, and it makes sense that in some ways we are working towards the terrestrial observation and prediction system, right? Like we're in that vein. We're not worried about the ocean assimilation and the ocean models. But you're right, Brian. This is the problem with acronyms, right? And so to me, I think this is another piece that is just really important in terms of our communication and science that we hope to see in some of those IVSS in the science symposium, as well as just in what students are learning to spell things out, because it's actually more inclusive and it leaves people less wondering, are they part of this community or are they not? You know, sometimes with these jargon or with certain terms like this. So I just kind of want to encourage all of us to you know, say what we mean, and make sure that you call Brian and I out, and Peter as well, Peter Falcon, if we end up falling into any of these traps that we're saying things and you don't know what we're talking about, because there really could be multiple meanings for an acronym like RSET.
Yeah. And the other thing is this tops of terrestrial observation prediction. The other tops, which we talk about, which Peter was talking about, which we're really getting into with NASA right now, is transform to open science. So yeah, so there's a whole, you know, I'm not sure why they decided to do two tops, but they both exist. So, you know, I actually corrected myself as I was thinking about it. So I realized, wait, there's two of them. So, but as you know, we speak in acronyms at NASA. Even, you know, our name is an acronym. So, but yeah,
Exactly. I know, right? Like, how many times do we actually spell out what NASA really is?
yeah.
Yeah. Marcus, I'm going to get you the correct link as well. So I saw that in the chat, but I just wanted to highlight that. And here I will actually, for everybody, here is the direct link to this particular training. And I want to highlight that I'm excited about this training because it also comes in Spanish. So it's a great introduction sort of hook when you are trying to describe why you're doing Globe, what Globe Observer is, how communities can be involved, that there is both an English version of this training and a Spanish version. And so I just want to mention this as part of that training resource, because we want to provide this connection to the remote sensing, so that that's why you come to our webinars. Why it's different than any other program is because we're not just looking at what you see on the ground and this human perspective, but we're also trying to give you this global perspective in both space and time, thinking long-term, thinking like a tree that will still be there in 2070. What is its life going to be like? And if people go back and re-interview, you know, the kids of today, you know, what are they going to be saying in those videos of the future? So that's it, Brian.
Thank you, Marcus, for saying about that YouTube link, because as of yesterday, I was on, Peter, so you know, I was on the RSET site, and that YouTube link was the direct link to the your presentation, and it's already gone. I just went in and looked, and it says it's not available anymore, and that was less than 24 hours ago. It was there. So thank you, Marcus, for doing that, and thank you, Peter, for putting in the link directly to that training. So yeah, I apologize.
Error checking, Brian. It works in all cases. Like, you know, this is, you know, the other thing is, like, just because you have an answer and it works one day doesn't mean it's going to work the next day, right? So it's the research piece that we as a community really rely on, these double checks like this. And so yeah, another demonstration of that.
Yep, never assume an assumption is your final result.
Right, exactly. Double check it, triple check it. Use lasers if you can.
Yep. All right, everyone. Thank you. We are just about at time. So just want to say thank you for this, and thank you, Peter, for the all the amazing discussion today. And Peter Falcon for going through all the questions there, because there were some great questions in the chat. And once again, apologize for the touchy Zoom today. So, but yeah, thank you all for this. And, you know, feel free, as Peter mentioned, to reach out to us at any time. And I know that, you know, may have more questions, and hopefully you do, about the, you know, the videos, the 3 to 5 minute videos, because we kind of just sprung that on you, you know, but we don't want it to be a burden, but we don't also expect to get, you know, it would be great to get hundreds of them. We don't expect that, but we really love to focus on some of them, you know. And I know some of you are definitely champion Globe folks out there, you know, who are here at just about every Trees Campaign webinar. And I know a lot of you participate in the multiple webinars, and the 20 Mike Jabot clones out there on every webinar at any given time. So yeah. So thank you all for this, and I'm going to stop the recording right now. And oh, sorry, we will see you back on hopefully the 7th of March for our next webinar, and that the highlight will be on the Jedi mission and a lot of the things that Peter was talking about, a little more in depth of what Peter discussed today and what we discussed today during the webinar. We will go into that a little deeper. So thank you, everyone, and once again, happy Valentine's Day. You know, eat lots of chocolate if you can, and you know, get out and take some awesome observations, either you with students and family. So
Go hug
thank
a
you.
tree.
Yeah, hug a tree. Yep. Thank you so much.
Bye, everyone.